morning, children. In today's class, we are going to proceed with problems based on NCR equals n factorial by n minus r factorial into r factorial. Question number 6, exercise 4.3. If n plus 1 C8 is to n minus 3 P4 equals 57 is to 16, find n. In this question, we have NCR as well as NPR. Remember, NPR is n factorial by n minus r factorial. NCR is n factorial by n minus r factorial into r factorial. Is 2 tells we need to divide. So it is n plus 1 C8 by n minus 3 P4 equals 57 by 16. Cross multiplying 16 into n plus 1 C8 equals 57 into n minus 3 P4. Applying this formula, it is 16 n plus 1 C8. How do we write it? N plus 1 C8, 8 numbers I must write. Either I can use factorial formula or remember n plus 1, the previous number n minus 1, n minus 2, n minus 3, n minus 4. How many terms I must write? 8 terms. 1, 2, 3, 4, 5, 6, 7, 8 terms. N plus 1, n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, n minus 6 divided by 8 comes 1, 2, 3, 4, 5, 6, 7, 8. The RH is 57 into n minus 3 P4. Permutation also same procedure. So n minus 3, n minus 4, n minus 5, n minus 6. How many terms should I write? 4 terms. 1, 2, 3, 4 terms. By will not come in permutation. Combination, divide by 1 to 8. In permutation, this is my answer. In both the sides, what all shall I cancel? N minus 3 to n minus 6 I can cancel. So what is left out? 16 I can cancel. 8 2s are 16. The remaining n plus 1, n minus 1, n minus 2, 3 into 4 into 5 into 6 into 7 into 57. Now in the previous exercise we did a problem like this. 4 consecutive numbers. The RHS try to write as 4 consecutive numbers. For which? Try to factorize this. 57 can be written as 3 into 19. So I will try to write the numbers near 19. Either previous number to 19 or next number to 19. See what all I can say for 19. I can combine these two, which will become 21. I can combine these two, which will become 20. I can combine these two, which will become 18. I need 4 numbers. Check whether I get 4 numbers. 18, 19, 20, 21. So we have 4 numbers. How to write it? Here it is in decreasing order. So here also I must write it decreasing order. Decreasing order, it is 21, 20, 19, 18. The LHS is n plus 1, n minus 1, n minus 2. Check whether it is right. 21, n is 20, n minus 1, 20 minus 1, n minus 2, 20 minus 2. So it exactly suits. Compare the second number and second number, or I will say n equals 20 and that is the answer. So we are able to find out the n value. Question number 7. Prove that 2ncn equals 2 power n into 1 into 3 into and so on up to 2n minus 1 by n factorial. Again we use the formula NCR equals n factorial by n minus r factorial into r factorial. Here the question is 2ncn. Let us start with LHS, which is 2ncn. Applying in the formula 2n factorial by 2n minus n factorial, n minus r, subtract these two, into n factorial. How to write 2n factorial? 1, 2, 3, 4, 5, 6 and so on up to 2n divided by, what is 2n minus n? N factorial. What is n factorial? 1, 2, 3 up to n. Look at the RHS. Denominator n factorial we will retain as it is. The other one we don't want in the RHS. How to cancel? The other clue is the numerator has only 1, 3 like that. That is, we need only the odd numbers. So to split odd and even in the numerator, we must know what is 2n. 2 into any number is definitely an even number. So what is the previous number? 2n minus 1, and obviously this is odd. 2n is even, 2n minus 1 is odd. So combine all the odd numbers, it is 1, 3, 5 and so on up to 2n minus 1. Combine all the even numbers, 2, 4, 6 up to 2n. The denominator we have n factorial into 1, 2, 3 up to n. To cancel up and down, remember this idea. If I have 2 into 4 by 1 into 2, this I can cancel one time, this I can cancel one time. How many 2's we are left with? 2 power 2. Suppose I have one more number. I can cancel, now it becomes 2 power 3. Suppose I have one more number. Now I have one more 2, it becomes 2 power 4. So what I see, the denominator is 2, 2 power 2. The denominator is 3, 2 power 3. The denominator is 4, 2 power 4. So when I cancel these two, the denominator is n. So this will become 2 power n. So what is left out? 2 power n into 1, 3, 5 up to which number? 2n minus 1. The left out denominator is n factorial, which is nothing but the RHS. So we started from LHS and arrived at RHS. The most important idea is cancelling this. When it is 2 into 4 by 1 into 2, I get 2 power 2. When it is 2 into 4 into 6 by 1 into 2 into 3, I get 2 power 3. When it is up to 4, 2 power 4. When it is up to n, 2 power n, and that gives rise to the RHS. Hence the result is proved. Exercise 4.3, question number 8. Prove that if 1 less than or equal to r less than or equal to n, then n into n minus 1 c r minus 1 equals n minus r plus 1 into n c r minus 1. Start from LHS, n into n minus 1 c r minus 1. Apply the formula NCR, n factorial. Here n minus 1 factorial by n minus r, subtract n minus 1 minus r minus 1 factorial into r minus 1 factorial. So we just apply the formula. Wherever n comes, I put n minus 1. Wherever r comes, I put r minus 1. Simplify this, n into n minus 1 factorial. Let us go on to this formula. What is n factorial actually? 1, 2, 3 up to n. What is the previous number? N minus 1. So I can write this 1 to n minus 1 can be written as n minus 1 factorial into n. So wherever n minus 1 factorial into n comes, I can put n factorial. So n into n minus 1 factorial becomes n factorial. Denominator, simplify this, n minus 1 minus r plus 1 factorial into r minus 1 factorial. This I can cancel minus 1 and plus 1. So I am left with n factorial by n minus r factorial into r minus 1 factorial. Just see the RHS. I want NCR minus 1. So let me start writing RHS answer. What is RHS? N minus R plus 1 into N C R minus 1. Apply the formula. N minus R plus 1 into, what is N C R minus 1? N factorial by, subtract N minus R minus 1 factorial into R minus 1 factorial. That is n minus r plus 1 into n factorial by n minus r minus into minus plus 1 factorial into r minus 1 factorial. The RHS, I have r minus 1 factorial. LHS also, I have r minus 1 factorial. So these two are correct. But here I have n minus r plus 1, but here n minus r is coming. The numerator, this is extra. So what should I do? Multiply this term up and down. So I get n minus r plus 1 into n factorial divided by n minus r plus 1 into n minus r factorial into r minus 1 factorial. Compare this part and this part. The numerator is proper now. LHS and RHS, it is one and the same. R minus 1 also correct. Only this part I must rewrite. So write this formula. What is n minus r plus 1 factorial? N minus r plus 1 factorial can be written as 1, 2, 3 up to n minus r plus 1. What is the previous number? Forget 1. That is the previous number. That is n minus r. So I can combine and write 1 to n minus r is n minus r factorial into n minus r plus 1. That is what I have in the LHS. So n minus r factorial into n minus r plus 1. I can write n minus r plus 1 factorial. Applying that here, the LHS becomes n minus r plus 1 into n factorial by joining these two from this step, n minus r plus 1 factorial into r minus 1 factorial. This and this are equal. Call this as 1 and this as 2. 1 comma 2 implies LHS equal to RHS. Hence we prove that n into n minus 1 C r minus 1 equals n minus r plus 1 into n C r minus 1, and that is the question. Question number 9, subsection 1. A kabaddi coach has 14 players to play. How many different teams of 7 players could the coach put on the court? There are 14. He is selecting a team of 7. A team of 7 can be selected from 14 in 14C7 ways. How to find 14C7? 14, 13, 12, 11, 10, 9, 8. How many numbers should I write? 7 numbers. 1, 2, 3, 4, 5, 6, 7. Divided by 1, 2, 3, 4, 5, 6, 7. Cancel and write the answer. It is 3, 4, 3, 2. Subsection 2. There are 15 persons in a party, and if each two of them shake hands with each other, how many handshakes happen in the party? 15 persons are there. Every 2 persons are shaking hands. So out of 15, we can choose 2 in 15C2 ways. So there are 15C2 handshakes are there, which is 15 into 14, right? 2 numbers by 1 into 2. Cancel 105. So number of handshakes equal to 105. The question is, how many handshakes happen in the party, which is 105. Subsection 3. How many chords can be drawn through 20 points on a circle? A chord joining any 2 points on the circle. Therefore, to draw a chord, we need 2 points. How many points are given? 20 points. How shall we select? So 2 points can be selected from 20 in 20C2 ways. 2 points can be selected from 20 points in 20C2 ways. How to calculate 20C2? 20 into 19 by 1 into 2. Calculate, it is 190. So we can draw 190 number of cards. Subsection 4. In a parking lot, 100 one-year-old cars are parked. Out of them, 5 are to be chosen at random to check for pollution devices. How many different sets of 5 cars can be chosen? How many cars are given? 100 cars. How many sets do we need? 5. A set of 5 cars we need. How many ways can we do? 100C5 ways. How to calculate 100C5? 100, 99, 98, 97, 96 by 1, 2, 3, 4, 5. See, 100, we have to write 5 numbers. 100, 99, 98, 97, 96. Divided by 1, 2, 3, 4, 5. As we simplify, we get 7528, 7520, and this many sets are possible. Subsection 5. How many ways can a team of 3 boys, 2 girls and 1 transgender be selected from 5 boys, 4 girls and 2 transgender? Given 5 boys, 4 girls and 2 transgender. How many do we need to form the team? I want 3 boys, 2 girls and 1 transgender. How to write the combination? From 5 I need 3. 5C3. And tells me multiply. 4 I need 2. 4C2. And 1 transgender. 1 from 2. 2C1. Multiply it all and write the answer. Let us do the calculation. 5C3. 5 into 4 into 3 by 1, 2, 3. Cancel, it is 10. 4C2. 4 into 3 by 1 into 2, it is 6. 2C1, whenever 1 is coming, 2 is my answer. Same number will come. Multiply it all. 10 into 6 into 2. So, it is 120. So how many teams can be selected? We can select the team in 120 ways. We can select the team in 120 ways, and that is the answer. Question number 10. Find the total number of subsets of a set with 4 elements. 5 elements and n elements. Let us find out for 4 and generalize the result for the other 2. A set has 4 elements. How will you write the subset? We know empty set is a subset of every set. So set having no element. Then we will write for subsets all 1 elements, then all 2 elements, then all 3 elements, then 4 elements. Maximum 4 given in the set. So set having 4 elements is the final idea. How many ways? There are 4. I want no element means 4C0. There are 4. I want 1 element 4C1. There are 4. I want 2 elements 4C2. There are 4. I want 3 elements 4C3. And finally 4 elements. That is all the elements I am choosing. The given set is a subset of itself. It is 4C4. Add it all. We should remember a formula which we will study in detail in binomial theorem in the next chapter. NC0 plus NC1 plus NC2 and so on up to NCn is 2 power n. Here 4C0, 4C1 up to 4C4 is nothing but 2 power 4. With a similar argument, I can say a set having 5 elements will have 2 power 5 subsets, and a set having n elements will have 2 power n subsets. Question number 11. A trust has 25 members. How many ways 3 officers can be chosen? Given 25 members, any 3 can be chosen in 25C3 ways. How to calculate? 25, 24, 23 by 1 into 2 into 3. As we cancel, the answer is 2300. Second subsection. In how many ways can a president, a vice president and a secretary be selected? Here order is not important. From 25 we choose 3. No other condition. But here, given 25 members, from 25, 1 person can be selected as a president in 25C1 ways. 1 person is gone. Remaining 24. From the remaining 24, 1 vice president is there. 24C1 ways. Now out of the 25, 1 president, 1 vice president is gone. So we are left with 23 people. From that we select a secretary in 23C1 ways. Multiply it all because we want the total number. We want a president, a vice president and a secretary. Whenever we have the word and, multiply. 25C1 is nothing but 25. 24C1 is 24. 23C1 is 23. Multiply 25 into 24 into 23, which reduces to 13,800, and that is the answer.